right? We had our 4142 quiz. So now the next several days, we're going to be working on the different parts of chapter 4. This is called conics. All right, so everybody go ahead and pull this up. The different conics that we're going to talk about are circles, ellipses, parabolas, and hyperbolas. You can kind of see where they come from. If you take a cone and just cut right through the cone, like left to right horizontally, if you were looking at it from the top, that would form a circle. So if we took our 3D object of a cone and cut it diagonally and looked at the picture from the top, it would be an ellipse. If you took the cone and just cut it like from the open part down to the side, that's where your parabola, your U shape. And then if you notice, if you cut it vertically, top to bottom, it creates two parabolas going in opposite directions. Those are called hyperbolas. So we're going to talk about the equations of those different things and how to find all that good stuff. Today we're going to talk about the mechanics of parabolas. Half of the parabolas you already know how to do because we've done them before. The other half, instead of these ones that we're going to talk about today, some are going to go up and down. And what do you think the other ones are going to do? Open which way? Left and right. Good. If a parabola, just think about this. I'm not even taking any notes or anything right now, but if a parabola opens upwards, is it positive or negative? Positive. So it opens downwards, it's what? Negative, okay? What about if it opens to the right? On the x-axis, what are the values on the x-axis to the right? Positive or negative? Positive. So if a parabola opens to the right, it's positive. And if it opens to the left, it's what? All right, so we're going to go over some vocabulary and stuff here. This is an important slide. Don't get hung up, and I have to memorize everything today right this second, but you need to understand the workings of a parabola. So the parabola is a set of all points, an x and y in a plane, that are equidistant. What does the word equidistant mean? Equally distant. Very good. From a fixed line. That fixed line is called the directrix. Directrix. All right, your fixed line in a plane, all the points are equidistant from the directrix. And a fixed point called the focus. It is not on the line. Okay, now looking at this picture, well, we'll talk about that in a second. The midpoint between the focus and the directrix is called the, anybody know? Vertex. Passing through the focus and the vertex is the axis. All right, so we have our vocab words there. You can look, oh, vertex doesn't look good. Do a different color. Is that better? All right, let's look at this picture. We're going to talk about some different things to kind of help you. Guys, look at the axis. What is the axis doing to the parabola? Cutting it in half, right? Are we familiar with the axis of symmetry? Are you guys also familiar with the vertex? Right? It's the either very minimum or maximum point. In this case, it's a minimum because it's at the bottom. But it could go left and right. So it could be to the left, could be to the right. What's kind of new here is the focus and the directrix. The directrix is a line. It's like a boundary line that is equidistant from the vertex and the focus. So say this was 2 units right here from the vertex to the focus. What is the distance between the vertex and the directrix? 2. It's always going to be the same, equidistant. What is the main thing to remember is your parabola is going to open. This is a good thing to remember. It opens towards the what? The focus. And it opens away from what? It opens towards the focus and away from the what? Directrix. Good. It's very directrix. It opens towards the focus and away from the directrix. Notice the focus is inside the parabola and the directrix is where? It's not inside the cup, it's where? Outside of it, underneath it, okay? Depending upon which way the parabola opens, it's always going to open towards the focus and away from the directrix. You'll see why that's important in a minute, because they might tell you the value of the focus, or they might tell you the value of the directrix. So if you know where the focus is, you know which direction the parabola is opening towards. If they tell you where the directrix is, you know the way the parabola is opening away from. Does that make sense? A little bit? Okay, so let's talk about the standard form of an equation of a parabola. We're going to talk about a parabola that is centered at 0, 0, your vertex. And we're going to talk about one that moves from the center. So what I want you to write down, we have two different formulas. We have x squared equals 4py. And we have y squared equals 4px. So let's talk about these two formulas that we see. Let's talk about the x squared one. If we compare these two formulas, how are they similar? How are they the same?
They both equal, both the p's don't equal 0.
Okay, both the p's in this case don't equal 0. If you look at the formulas just themselves, what is exactly the same? The 4p. Okay, so that's going to be important to recognize that. What do you think the difference is if one starts with x squared and one starts with y squared?
One is going to be on the x-axis.
Correct. One is going to be your vertical up and down, as one is going to be your which way? Horizontal left and right. So this mathematically, you guys can handle all the math computation in this. This is going to have us being like, okay, it's x squared, so it goes this direction. It's y squared, so it goes this direction, that sort of a thing. That's important for you guys to remember. Now, if you were going to plug this in your calculator, right, I know it says x squared equals, so if you solve for this, excuse me, if you were going to plug this in your calculator, which way would the x squared parabola go? You guys have seen this a million times already. Which way does our x squared go? Any of the parabolas we've talked about, what direction did they open? Up and down, okay? The up one is what? The down one is. So if you have a parabola that has a positive p-value, it's going up. If you have a parabola that has a negative p-value, what do you think it's doing? It's going down. Does that make sense? Because if you have a vertical parabola, if you have an x squared, it's going to go up or down. So then we can say, okay, it's an x squared, I know it's up and down. If the p-value is positive, it's going up. If the p-value is negative, it's going down. Question? We'll get there in a second. The next line, no, you're fine. The next line tells us that. Okay, so now that we've established that we know our x squareds, what does the y squared do? It opens which way? Left and right. Good. It opens left and right. Now think about, guys, on the x-axis, I know I'm saying x-axis, but if a parabola is opening left and right, right, that's our y squared. It's laying downwards. If it opens to the left, what values is it pointing towards? Negative ones or positive ones? So if your p-value is negative, your parabola is going to the left. If your p-value is positive, your parabola is going which way? To the right. So just think about that. On a coordinate plane, if your parabola is going upwards, it's going towards positive values. If it's going downwards, it's going towards negative values. If we're going to the right, we're going towards positive values. If it's going to the left, you're going towards what? Negative values. Okay, good. All right, another thing I want to talk about in this case is your directrix. Which way does our parabola open towards? Towards the what? Towards the focus and away from the directrix, okay? So in the case where it says P is not 0, and we're at the origin, we're not moving left and right. We'll talk about left and right in a second. The value of your directrix is always going to be a y equals or an x equals, and then your focus will be like this. And we'll talk about this in a second. Here, I was in pink, right? So x equals negative p, and your focus is p, 0. Now again, when we put numbers to this, you guys are going to be like, okay, this makes more sense. But remember, your focus is a point. Your directrix is a what? A line. Good. It is a line. Y equals What does that line look like if it's y equals? It is horizontal. It's left and right. Good. What does x equals look like? Up and down. All right. Good. See, all of this stuff is good to be able to visualize. Then this last sentence is very important. It says the focus lies on the axis p units from the vertex. So Hannah just asked a great question. She said, what is the p? That is like the main thing that you guys need to know. After you identify which direction your parabola is going, p, write this down, is the distance between the focus and the vertex, and I should say, what's the p-value? Okay, but it's the distance between the focus and the vertex, or what in the vertex? Good, directrix in the vertex. What is the difference with those two things? The value, if I tell you p is 2, is the value different or the direction? The direction, because the vertex, remember the parabola opens which way? No, not necessarily up, but towards the focus and away from the directrix. So if they tell you that the p-value is 4 and the directrix is, y equals whatever, then from that directrix you would go 4 units and then you would go in your parabola would open the opposite direction. If they told you that the vertex was here and the focus was here, it would go towards the focus. That's really, really important to remember those two things. You guys got it? Okay, so let's go through some problems. Let's put some numbers to this and kind of look at some things. The first thing you need to do when you see these is you're like, okay, I have one variable squared, because once we get all of these together, you need to first recognize what conic they're talking about. Is it a hyperbola? Is it an ellipse? Is it a parabola? Obviously, this is a parabola because I have one variable squared and the other one is to the first power. So I look at this and I say, okay, x squared equals 8y. What kind of a parabola is this? It's an x squared parabola, correct? Okay, it's an x squared. I'm going to give, whoops, why am I doing that? I'm going to give myself, it's an x squared. Meaning, which way does my x squared parabola open? Up or down, okay? That's a good thing to do, guys. Give yourself an idea. Now, this parabola is centered at 0, 0. Your vertex is at 0, 0. You know that, and you'll be able to recognize it a little more because you don't have any parentheses that are moving it left and right. You'll see the difference here in a second. All right, so I have some information already. I can go ahead and say, okay, if I'm going to graph it, I know my vertex is right here. And I know my parabola is opening which direction? Why? Because it's positive. Good. So now let's think about the equation of an x squared parabola. It's x squared equals what? 4py, correct? How do we figure out what that p is? Divide what by 4? I like it. I like that thinking. Do you guys see what you said equal to each other and solve? 4p is equal to what number? 8. So I say 4p equals 8. What do I do to both sides? Divide by 4. So p equals what? 2. The distance from the vertex to the focus is how many? 2 units. In what direction? Why do you guys know for a fact it's up? Because the parabola is positive. You knew that. So right there is your focus. Good. So if I asked you, well, okay, fine, you guys know where the focus is. Your focus is at 0, 2. Well, then where is your directrix? 2 down. It's down here, correct? And it's just a line like this. What is the equation of that line? Y equals -2. Perfect. And what does your parabola look like? Just up. Does that make sense? Now, the hardest math you had to do there, guys, was 8 divided by 4. Okay, can we handle that? Yes. Is this a lot of things? You're like, whoa, wait a second. So we're going to spend a few days on this. Let's look at number 2. Let's go through it methodically. Methodically means, okay, let's take our time, identify this stuff. First of all, let's go ahead and say what our vertex is. Where's your vertex? It's at 0, 0. You'll see in a minute when it's not at 0, 0. So my vertex is 0, 0. What kind of a parabola is this? It's a left to right. How do you know it's a left to right? Because it, whoops, y squared. Good. Very good. So think about what your y squared formula is. It's y squared equals what? 4px, correct? Okay. Now we can go one step further. Here's my vertex. I can go one step further and say, which direction is this opening? Is it opening to the left or to the right? How do you know it's to the left? Awesome. Good job, guys. So what do I set equal? I'm going to say, well, 4p equals what number? Negative 28. Great. So I divide both sides by 4. And p equals what? Negative 7. Remind me again what that negative 7 is. It's the distance from where? The focus to the vertex, or the vertex to the directrix. So my focus is going to be negative 1, 2, 3, 4, 5, 6, 7, right? You guys agree? That's my focus. We're at negative 7, 0. Where is my directrix? Positive 7. 1, 2, 3, 4, 5, 6, 7. So this is at 7, 0. That's my directrix. So this is the line. And which way does my parabola open? Towards the what? Towards the focus and away from the directrix. Say that again, guys. Towards the, away from the, okay, super important to remember that. All right, let's go. Oh my gosh, it's hot. Okay, stop complaining about the heat. I believe it's not working like it normally does because we're not all frigid. Does this make you not want to complain about the cold that much? How many of you would rather be hot like this? Okay, same way. All right, where's my vertex? It's still at 0, 0. We're not moving left to right. Is this set up exactly the same way as before? Think about what our two formulas are. It's x squared equals 4py, right? Or y squared equals 4px. What do I need to do first? I need to isolate. I got to get x squared by itself. So I'm going to divide both sides by 4. Everybody agree? So when I rewrite this, it's x squared equals, what's another way I can write divided by 4? What's the same as dividing by 4, multiplying by what? 1 over 4, good. All right, so let's talk about our parabola. Talk about a parabola. Is it a positive or a negative? And then which way? Is it up or down, left and right? It's an up or down, good. And in this case, I know it's going to be positive or negative. It is positive. Why is it positive? Do you guys see any negative signs? No. Okay. So let's think about this. Our vertex is here. I know we're going upwards. Like you should have a good vision. So that means your focus is going to be above the x-axis. Your directrix is going to be where? Below. Good. So what do I set equal to 4p? 1/4. So 4p equals 1/4. You guys agree? So what do I do? Divide both sides by 4 over 1, correct? So p equals, if I keep change flip, 1/4 times 1/4 is 1/16. Is that okay? Are we allowed to have that? Sure. So if I have, if I'm going to plot this, my focus is going to be right here at, what's that point? 0, 1/16. That's my focus. So where's my directrix? Down here at what? 0, negative 1/16. Perfect. And which way is my parabola open? Tell me again. Towards the and away from the directrix. Repeat that 5,000 times.
For the directrix, you write as a coordinate?
No, you're right. I'm sorry. I should have written that y equals negative 1/16. You're right. You are correct. All right, let's look at the next one. Again, same thing. Let's think about. All right, what do I need to do first? I know that my vertex is where? I know it's at 0, 0. Did not move left or right. That's good. I either have my formula of x squared equals 4py or y squared equals 4px. Which one is this? X squared or y squared? This is a y squared parabola. So I'm going to rewrite this so I isolate my y squared. So I'm going to divide both sides by 8, correct? So y squared, I'm going to rewrite it as 1/8 x. Is this a left or right or up and down again? Left and right, good. And is it which direction? Positive or negative? Positive, good. God bless you. So it's opening to the right. So let's draw a quick little picture. Let's just get it started. My vertex is here, and I know my parabola is opening to the right. So how do I figure out how far away my vertex and my directrix are? 4p equals 1/8. Perfect. Divide both sides by 4/1. So p equals, if I have 1/8 times 1/4, it's what? 1/32. Oy, bad color choice. So I know that my focus is to the right. So my focus, we're just going to put it here. And what's that point? 1/32, comma what? 0. And then where is my directrix, that line? It's to the left, correct? And it's at x equals or y equals? X equals -1/32. And then which way again is my parabola open? To the right. It's opening towards the focus, away from the directrix. Good.
How is it x equals going horizontal?
It's not going horizontal, it's going vertical. Through the x-axis. Your directrix. Not the parabola. The parabola is a y equals.
Oh.
But the yellow line is going through. Right? Okay. All right, let's go to the next. All right, this is not going to be any harder, I promise. I promise. Do you guys remember vertex form from our parabola? We had like f of x equals a times x minus h squared plus k. What was h and k? The vertex. Same exact thing, guys. This is the equation of a parabola. So it's just written a little differently. So here we go. What did I do? X in blue, right? So write this formula down. X minus h, that doesn't look pretty, squared equals 4p times y minus k. Everybody agree? Okay, and then in pink, I'm going to have y minus k squared equals 4p times x minus h. Now, again, what we're going to do is identify the vertex and our p. In this case, our vertex will make itself apparent. You'll be able to see it, but it's not going to be 0, 0. But notice, guys, notice. In your vertex, what is the h part of your vertex? What letter? It's the x, right? And then what is the k? It's the y. Do you notice in the formulas the h and the k are the h and the x are together? The y and the k are together. Pay attention to that. The x stays with the h value. The y stays with the k. So now we got to think just a little bit more what we're looking at. But p is still how far away the focus is from the vertex. We okay so far? Let's do a couple problems and you guys will be all right. Promise. How many do we have? All right, 3 more. Okay, so if you need to, go ahead and say, okay, wait, what are the formulas again? X minus h squared equals 4p times what? Y minus k? Or, what's the other one? What is it? Y minus k squared equals 4p times x minus h. All right, you got to figure out which one we're looking at. So look at this first example. Which variable is squared? The x or the y? The x. So go ahead and say, okay, oh, this is the one we're looking at. We're looking at the x minus h squared equals 4p times y minus k, right? You're looking exactly at that. So let's first identify the vertex. Can anyone tell me what the h part of my vertex is? +3, Richard says. How come he changed that sign? You are correct. What is in the formula? X minus, right? So just like in our standard form that we did before, when you take it out, if it's minus, it's going to change the sign. So my vertex is at 3 comma what? What is the y part? Negative 2. You're always going to change the sign when you pull it out. Okay, so we know where our vertex is. Go ahead and plot that. Find it, say 1, 2, 3, down 2. Here is my vertex. It's at 3, negative 2. All right, good. Now let's think about it. Do I have an x squared parabola or a y squared parabola? X squared. What direction does x squared go? Up and down. Okay, good. We've got to get an idea of where it's going. Is it positive or negative? It's positive. So now you guys have an idea of what your parabola should look like. It moved over 3, down 2. It's going in the up direction. If I asked you guys what the axis was, that line that's going to cut it in half, what would you tell me? X equals 3. Awesome. That's your axis of symmetry. Perfect. Perfect. All right. What else do we need to graph this? What else should we find? Where's our focus? Where's our directrix? How do we know? Okay, think about this, guys. Look at, this is why I like to write the formula underneath. How do you find the P? What is 4P equal to? 4P is equal to 4. Whatever number's out in front, you set that equal to 4P. So I'm going to say, oh, let me figure out how far away it is. So 4P equals 4. Divide both sides by 4. So what does P equal? P equals 1. What does that tell you about the focus and the directrix? The focus is where? 1 where?
Like the 1 comma 0?
No.
0 comma 0?
How far away is the vertex from the focus? How many units? 1. In which direction? Why is it 1 up, Abigail? You're right. Because it's a positive parabola. We know which way it's opening. So I know that my focus is going to be 1 up from there. What would that be?
0 comma negative 1.
No, my vertex is 3, negative 2. So if I went 1 unit up,
2 comma negative 1.
it would be 3, comma negative 1. I went up 1 unit from 3, negative 2. If you count up 1, you're then at 3 where? Negative 1. So where would my directrix lie? My directrix is going to be at 3, negative 3, correct? It's going to go down 1, and it's going to be a line. So how would we write that equation? Y equals negative 3. All right, there's a lot of thinking that's involved here. You guys are going to you have to be able to visualize. You have to say, okay, what direction is the parabola going? Which way? And we want to be as, excuse me, we want to be as exact as possible. So let's go ahead and find a y-intercept. Let's go ahead and find a y-intercept. How do we find a y-intercept? You guys see that? Y-intercept. What do we plug in for a y-intercept? Set x equals 0. Okay, so let's go ahead and do that. So we'll say 0 minus 3 squared equals 4 times y plus 2. You guys with me? Okay, can we simplify this? What's 0 minus 3? Negative 3 squared is? 9 equals 4 times y plus 2. All right, now what? Okay, distribute the 4 if you want to. So 9 equals 4y plus 8. Now what? Subtract 8. So 1 equals 4y. So y equals what? So your y-intercept is at 0, 1/4. So at 0, 1/4, you have a point. Do we now have a pretty good picture of what our parabola is going to look like? Yes, it's going to go through the vertex, through the y-intercept, and open towards the what? Towards the focus, away from the directrix. Say it, guys, towards the focus, away from the directrix. When you have your test, you're going to have parabolas, ellipses, and hyperbolas, not just one thing. So there's a lot to remember from this. Let's try and go through this a little quicker in this one. Little quicker. All right, first thing I'm going to establish is obviously we're not at the vertex, right? We're not at the origin. We're moving places. But is this an x squared or a y squared? This is definitely an x squared. This is an x minus h squared equals 4 times y minus k. All right, is my x squared thing over there all by itself? No, so what should I do? We're going to go ahead and divide both sides by -4. When we do this, this becomes x plus 3 squared equals -1/4 and then y minus 2. There's no reason to have y over -4 minus 2. Don't do that. Just put the -1/4 in front. All right, so let's establish where is our vertex. -3, comma, +2. I agree. Okay, so let's go ahead and start drawing a little picture. So 1, 2, 3, 1, 2. Right there is my vertex. Everybody agree with me? Okay. I know this is what kind of a parabola? X squared or y squared? It's an x squared, so it's going to open up or down. All right, think about that.
Is that a 2 or a 12?
It's a 2. Just an errant mark on my part, sorry. Which way is this parabola going to open? Why is it opening down? Because the p value is what? Negative. That number in front is negative. That means, oh, wait, it's going downwards. Okay, good. So you guys should have a little bit of a mental picture that, okay, this is opening downwards. There's my vertex. So let's figure out what the p value is. What do I set equal to each other? 4p equals -1/4. Good. So we're going to divide both sides by 4. So p equals, if I have -1/4 times 1/4, what does that equal? -1/16. Wonderful. How far away is your focus from the vertex? Negative what? 1/16. How far is your directrix from your vertex? It's going to be 1/16 of a value. So if my vertex here is at -3, 2, the hardest math you have to do, guys, is figuring out what the other 2 points are. If my parabola is opening downwards, where is the focus? Down or up? It's down, okay? My focus is going to be down because your parabola opens which way? Towards the focus. Good. So my focus is going to be, just say it's here. I have to figure out what that is. If I move down, what do I affect my vertex? The x-axis or the y? The x or the y? From the point -3, 2, if I move downward, what am I affecting? The -3, am I moving left and right? Or the 2, am I moving up or down? The 2. So what is the value, what is the point of your focus? I went from 2 and I went down. So am I subtracting or am I adding?
Minus.
It's minus. So it's -3. And then what's 2 minus 1/16? So 2 over 1 minus 1/16. What is the common denominator? 16. So this becomes 32. What's 32 minus 1? So 31 over 16. Okay. So then my directrix from the focus, which way am I moving for my directrix? Am I moving down or am I moving up? Up. So my directrix is going to be this line here. But what is that y value? From 32 over 16, I went up 1. So it's what? 33 over 16. Good. And then how would you find the y-intercept? Plug in 0 for what? Plug in 0 for what? X. All right, I'm not going to do that right this second just because I want to get to the next. But the hardest math you're going to have to do is once you find your vertex, it's not at 0, 0, you have to figure out if you're moving up and down, you're going to add and subtract to the y. If you're moving left and right, you're going to add and subtract to what? The x. Okay, so let's go through this one, then we're done. What am I looking at here? A y squared. I see that my y value is squared. So which formula am I using? Y minus k squared equals 4 times what? X minus h. Okay, great. So I know now, I can figure out where my vertex is. Don't get confused. It's positive 3, positive 2. Why isn't it 2, 3? Because, guys, if you need to, put, H goes there, K goes there. I think it's really important, this step right here, writing out the original formula. So you see that, the H is the 3, the K is the 2. All right, so let's start drawing a little picture. My vertex is at 3, 2. 1, 2, 3, 1, 2. That's my vertex. Which way is this parabola opening? Left or right, up and down? Okay, left and right, because it's a y squared. Is it positive or is it negative? It's positive, so I know it's opening which direction? To the right. It might seem silly to you to draw all this stuff that I'm doing and circle it. I'm telling you right now, it'll help you. Because there's a lot of things you have to figure out here. All right, so let's find that p-value. How far away is the focus and the directrix? Well, what do I set equal? 4p equals what? 24. Whatever number's in front. So I'm going to divide both sides by 4, and p equals what? 6, all right? We like whole numbers. Makes life a little easier. So think about, from my vertex of 3, 2, my focus and my directrix are going to be in which direction? Up and down or left and right? Left and right, because you already told me it's opening left and right. So I'm going to add 6 and subtract 6 to which part of my vertex? The 3 or the 2? If I'm moving left and right, the 3. I'm going to go, 3 plus 6 is going to give me what? 9. So my focus is going to be at 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. There's my focus. Why did I make my focus to the right? Because the parabola is opening to the right, and your focus opens which direction? Sorry, the parabola opens which direction? Towards the focus. So now in order to find the directrix, I'm going to take the 3 and do what? Subtract 6. So 3 be here at what value? Negative 3. Your directrix is at y equals negative 3. Okay, so it's right here. The directrix is right here. X equals negative 3. And then we're going to go ahead and draw a parabola. We said it opened to the right. So you go towards the focus, away from the directrix.